Welcome. In today's lesson, we're going to take a look at an application of using a derivative. And this is actually one of the simpler applications. It's finding a marginal cost. Marginal cost is the derivative of a cost function. So if you're asked to find the marginal cost function, you're just asked to take the derivative of the cost function. Now in our text, they also ask us about finding average cost. It turns out the average cost problems aren't calculus at all. So let's take a look at this example. A product has the cost function, c of x equals negative 0.1x squared plus 40x plus 100. And then, so x is the number of products you make in these. That's the first thing to understand. X is how many things you make. So, the cost to make 100 items is when you make x 100. The cost to make 1,000 items is when you make x 1,000. So you can make as few as 0, in which case you still have a little bit of a cost here when you put 0 in, but that's like you got to get ready to make things even before you make them. There's money spent there. And then you can make as many as 1,500 for this cost function to be accurate. Maybe beyond 1,500 you need another line, you need some other things. So what we're going to do is look at finding the average cost. Now, the average of a list of numbers as you add them all up and divide by how many you are. So you find a total. So average is total divided by the number there were. Okay? I'm going to work on my handwriting here, but to find the total is c of x. So the cost to make x number of items divided by the number of items you made is the average cost. So you literally take this function up here and divide each term by x. Now you can write the division across the whole thing and divide by x, but I want to remind you that if you're dividing the function by x, you're dividing each individual term by x. That's an algebra mistake that people have a lot. So the average cost this cost function is going to be negative 0.01x plus 40 plus 100 divided by x, or that could be written as 100 times x to the minus 1. So that's how you find the average cost. You literally say, okay, this is the cost to make x items. I find out how much the total cost to make x items and divide by the number of items, and that gives you a cost per item. So that's in dollars per item typically. So that one's not even calculus, but the words do tangle you up a bit in these problems, I know. So let's go down to the next question. So that's the average cost function, and now we want the marginal cost function. The marginal cost function, and I'm going to do that down below part B. I didn't leave myself enough room, really. The marginal cost function is going to be the derivative. So I'll do the marginal cost function in a different color. So the marginal cost function, actually, I can do it right here, is simply c prime of x. That's your marginal cost function. And you look up at your cost function and you take the derivative. Now we're taking the derivative of the basic cost function, not with the x's on the bottom. We're not taking the derivative of the average cost. So for the derivative of negative 0.01x squared, I get negative 0.02x. The derivative of 40x is simply the 40, and the derivative of 100 is 0. So this is my marginal cost function right here. Just take the derivative. So far, this is not the hardest problem you've done all semester. And it won't be. Part B, determine the average cost and marginal cost when x equals 1,000. You are just asked to put 1,000 into each of these functions. So for the average cost, now let me be consistent and do that in the color I used for average cost. So for the average cost, you can see why I type out a lot of my notes here. When x is 1,000, you're going to put in negative 0.01. The trick here is to just keep track and make sure you're using the right function. Times x plus 40 plus 100 over 1,000. And you can evaluate that in your calculator. All right, I'm not going to do that out right now, but that's all you do. You use your calculator from there on. Now, to find the marginal cost when x is 1,000, you're going to put 1,000 in for x in your marginal cost function. So we'll do that here. So C prime of 1,000 is what I want when I want the marginal cost at 1,000. So I do negative 0.02 times 1,000 plus 40. And I will just do these two out on my calculator while you're catching up here. 1 times 1 negative, I'm doing the average cost, negative 0.01 times 1,000 plus 40 plus 100 divided by 1,000. I can do this without my calculator, but I want it to be accurate. It looks like I get 30.1 for the average cost. So the average cost per, and since it's dollars and cents, I'm going to make it $30.10. And for the marginal cost, and we'll talk about what the difference is between these two, I'm going to get negative 0.02 times 1,000 plus 40. And I'm going to get 20. So I get $30 is the average cost. Once I've made 1,000 units, on average, they each cost $30. But to make the next unit, that's what the marginal cost tells me. How much is the next unit? It's only going to cost me 20. So my average cost per unit is still going down. So you should, that tells you something if you're running a business. Should I, how much should I keep making more units, or should I stop here, or what is my setup still efficient? So your average cost is going down. So you'd want to look and you see where your average cost is going up and average cost is going down, or where your marginal cost is going up. This is kind of the cost to make the next unit. So that takes us to part C. Interpret the values obtained in part B. Well, I just talked about that. So the average cost is, if you take this $30.10 and multiply it by how many units you made, that's how much money you've spent to make those. But the marginal cost says, all right, how much is it going to cost to make the next unit when you've already made 1,000 units? It's only going to cost 20 to make the next one. So your average cost is going down, so it's worth it to keep that production line going. Might be a decision you made, but the average cost per unit is the cost to make the next unit will be 20. The average cost is 30. So that's the difference between an average rate of change and an instantaneous rate of change. All right, that's all you need to do for these cost problems. There are other more complex business applications where we start talking about profit functions and revenue and things like that. That's not going to be the focus in this course because there's no new calculus there. It's all taking derivatives and seeing what they tell us. But coming up with the actual profit and cost and revenue functions becomes a bit more complicated. In these problems, you're given the cost function directly. So really all you're having to do is the calculus, which is what we're interested here. But calculus does not just apply to sciences and engineering. It definitely has economics and business applications that you want to be aware of. All right, thank you for joining me, and email me any questions you have.